so section 1, 2 notes. This one should be fairly obvious because you dealt with it yesterday. Y equals mx plus b. I mean, these all should be a trip down memory lane since you took algebra 2 and algebra 1. Key thing here is that, y is by itself. It's solved for. In standard form, you have the x term and the y term on the same side and a constant on the other side. That shows up a lot in story problems. You'll see that format very easily converted from story problems. I bought 5 apples and 6 oranges for $10.30. That kind of thing. It's a very easy format to use in those story problem situations. And then the point slope form of the line y minus y1, which is equal to m times x minus x1. Which, that is really just a modification of the slope formula. Difference in y's over difference in x's. You notice that they just took the slope formula and basically cross-multiplied it. Which is, that's all they're doing. Any questions on those, since we've seen those before? What's the relationship between slopes of perpendicular lines? Relationship between slopes of perpendicular lines. What do you got? They are reciprocals and okay, opposites. Opposites and reciprocals, right? So you've heard that phrase before, opposite reciprocals. What's the new slope going to be? If you look at the equation of that line, y equals negative 2/3 x plus 5, what is the new slope going to be? What's the slope of the old line? Is it too small? What's the slope of the old line? Negative 2/3. So if I need the opposite and the reciprocal of negative 2/3, what would I get? 3/2. Where have you been? That is true. The new slope is going to be 3/2. Well, we know where the slope goes. We know where the x-coordinate goes. We know where the y-coordinate goes. Remember, your algebra teachers have said to you things like, and now you need to solve for y. Distribute the 3/2. Add the 5. To be honest, is this a line? Is this the equation of a line? Yes or no? Is this the equation of a line? Yeah, it is, right? Why do I need to change the form? Because my math teacher said I had to? Okay, alright. I guess they were just trying to exercise your brain. All they asked me for was the slope, equation of a line that's perpendicular to the one given? Well, there it is, folks. I'm not going to waste your time making you solve it for y. Now, if you can't sleep at night because it's not solved for y, okay, be my guest, solve for y. But I don't think it's necessary. Okay, whatever device you're going to use, whether it's the graphing calculator or Desmos on your computer, and that would be the graphing calculator version. Here, let me type that out here. If you are using desmos.com/calculator. So, if you want to use that, that's fine. If you want to use your handheld device, use your handheld device. But we need to get this data entered in. Now, if you're entering in the data with a graphing calculator, and you don't remember how to do that, we would do that like this. Okay, so let's clear this out. Stat. That stat button is kind of in the middle towards the top. And then enter, because it's already on edit. Now go over to your lists. Now if you have something in a list and you want to get rid of it, you go to the very top of the list, you hit the clear and the down arrow, and it gets rid of everything in that list. I've already got the data entered in, so I'm not going to retype it. Okay? But let me get you back this list. You've got it in front of you. What am I talking about? You've got it on paper in front of you. So get the data entered in. Now, if you're using Desmos, you'll want to go to this little plus button right here, click on it, and choose Table. And when you choose Table, then you can start entering your data. So get your data entered into one or the other. Alright, so how do we take a look at this data? Let's do it on the graphing calculator first. So, right above y equals, it says stat plot. Now, we're truly creating a scatter plot, but I don't think they wanted to abbreviate it scat plot since that's completely disgusting. Not sure anybody gets that joke, but okay. When we get into the scatter plot situation, we want to turn one of them on, and we want to make sure that the lists, I like to use the first one where the dots are scattered, and I'm going to change my list to list 1. I can do that by right above the number 1 on the keypad, so second. And then if you take a look at the best way to find the data when you're doing this on a graphing calculator is to do zoom number 9, zoom stat. Zoom stat will create the window surrounding your data so you don't even have to think about it. That is one nice feature of the graphing calculator. So it will automatically create the window for that group of information. Now, is it hard over here on this side to do it? No, because remember, I can grab 2 fingers on an axis and shrink the axes down until I get a good-looking picture. So now we've got the graph on both devices. Next, on the graphing calculator, if I want to find a line that goes between the data, this is called linear regression. I'm going to type stat, but this time I'm going to go over to the top where it says calculate, and I'm going to find the 4th one down, linear regression. If you have an older style calculator and you'd like me to show you the one that doesn't have this cool menu, just let me know. But if you have one of these, then you can come down here. We're actually going to store the regression equation, so we're going to actually put it into our calculator here. And I'm going to do that fast by doing this. Alpha, and then right up here, the trace button. And what that does is it creates a little window that has all my options of my different y variables. It's already highlighting y1, so I'm going to use that one right there. And once you have that selected, you can come down to calculate, and then you can hit enter and let the calculator figure out what the equation is. So those of you using the calculator, were able to follow that? Okay. Now, those of you using Desmos, you see this little button right here that says add regression? It looks like a line with some dots. Click on that. Now, at the bottom here, you have a drop-down menu which has all kinds of options. But the one we wanted was linear regression, so we're just going to leave it alone at linear regression. Obviously, that was faster on Desmos than it was on the graphing calculator. Same equation. 11.731 x plus 193.852. Next question, predict the calories of the grilled cheeseburger that has 79 grams of fat. Okay, is that an x value or a y value? Is that an x value or a y value? It's an x value. If you're on Desmos, you're going to type x equals 79. And literally, thanks for listening. You can literally find it on your graph by shrinking it a little bit and seeing the intersection point between the lines and find your answer at 1120.6. If you're dealing with the graphing calculator. On the graphic calculator, I would use the table feature. So for instance, I would make sure my table, which I would go to the table setup feature, which is right above the word window, and I would change that independent variable to ask. Once I had that set to ask, then I would change, then I can go to the table itself, and I literally can type in 79 and it will tell me 1120.6. So that's a tie. I don't know. I still like this much better, but the table is kind of a useful feature. Next, it says predict the grams of 800 calories. Is that an X or a Y? That's a Y value, right? So, over here, I'm coming, let's just do this. Y equals 800. Answer 51.7. Over on this side, I'd have to come back here and type y equals 800. I'm probably going to have to change, if I look at this graph, it does not include the y value 800. If I look at my window, I use the zoom stat, I can see that it stopped well below 800. So maybe I go to 850. Well, now I've got a problem because my x's aren't far enough, so now I got to go change my x's and make it farther that way. I don't know, 75, 80. Well, now it's on screen. And now I can do my calculate intersect feature. Calculate intersect. It's going to ask me if the first curve is the blue one, and my answer is yes, so I hit enter. Is the second one the red one? I'm going to hit yes by clicking on enter. It asks me if I want to guess. The answer is no, because there's only one intersection point, and then I can go find 51.7. easier on Desmos? Yes, it was. Anybody got a picture of it? Oh my.
Alright, so what do these graphs look like? Trip down memory lane for some of us. If you don't know what a quadratic, a square root, a cubic, and exponential are, or what they look like, that is a little bit concerning because we spent a lot of time in Algebra 2 studying what a quadratic looks like. You know, studying what a square root function looks like, studying what a cubic function looks like, and studying the exponential function, you know. So knowing things like the domain and the range, and I'll just go through, obviously, negative infinity to infinity here. But, you know, this one, oops, sorry, wrong already, 0 to infinity, because it bottoms out at 0, but does include 0. Domain here, 0 to infinity, and same thing for the range, 0 to infinity. This one is negative infinity to infinity for both the domain and range. And this one on the far left is negative infinity to infinity and 0 to infinity. Now pay attention to that the 0 is not included in that because of that whole asymptote of the graph. Remember that? That was a line it got closer and closer and closer to, but never touched it. We called it an asymptote and made a lot of funny jokes out of that one. In this case, it's y equals 0, just on a basic exponential function. But those were some things you should be aware of for the quadratic, square root, cubic, and exponential. Obviously, we'll be doing more with those things, using them, doing regression with them, all sorts of things. And moving them around, doing scale changes and reflections and all sorts of stuff, which we did some of those kind of things last year. So that should be kind of review. Let's see what's next. Okay, our next question is listed here. It's a list of data. And one of the things that we like to do, now if you're using a graphing calculator, this is going to be like list 1 and this is going to be like list 2. And then instead of using 1994, we're going to use 0 and then 1, 2, 3. Oh, nope. Back up. 0, 2, 4, 6, 8, and 10. So those will be the values that we use in list 1. And we can leave the y values in list 2 exactly the way they are. We just have to remember that they're in thousands. Okay, so that's really 50,000, 56,000. Okay, so and then of course, even on question 1 here, where we, if you are making your window for your friendly window to a scatter plot, I might do like 0 to 12. That way 10 is already on the screen. It's easy to see. Now we might have to expand this. You might have to change that because they might ask me other questions that go past that. That's one of the drawbacks of the graphing calculator. Now, you can make your own selection on what you want. You can start at 0. You would need to go up to, at least like 120, so that you go past 110. But we all know that it's going to start out at 50. So, all my dots are going to be like up here. So if you don't want to start out that y min at 0, you want to go, move it to, say 40, you could make it 40 if that's what you wanted to do. And then it'll look a little bit nicer. But I don't have my document camera here at home, so I can't show you on the graphing calculator. I will be showing you Desmos here in a second once I get the data entered in. Let me pause for that. And may I remind you that to make a table, you're using the plus sign up here, and then you can come down to table. That's how I got this table in Desmos, and then I was able to type in the information. And as you can see, my graph doesn't look the greatest, so I'm going to hit the little house button and go back to the beginning. Obviously, these values aren't the greatest, so remember how we put 2 fingers on the axis that we want to change, And then I'm going to shrink this down and see if I can find my values. Ah, there they are. Okay. Now there's a very distinct curved shape here. It does not appear to be linear. In fact, if I were to use linear regression, you can see that this dot is above the line. It hits the line, goes below the line, and then comes back, hits the line, and goes above. So that's showing me a very curved pattern. Now, the better question is, which shape is it? Does it look like a quadratic? Well, that's looking pretty good, I know a quadratic has both sides to it, but we're really just seeing if these dots right here follow a quadratic pattern, and that's a pretty strong case for the quadratic. Now, the information that we see here is useful, but I also think that maybe this could be exponential. So let me take a look at the exponential regression. And I see that it does look pretty good in here, but I'm not really all that convinced that it's better. I'm going to say that we're probably looking at the quadratic model. It hit this point better, so it just seemed like it fit a little bit better to hit the data. So I'm going to say this is a quadratic, right? Determine the function that best represents the data. So without having super great statistical knowledge of what different models, of the reason why one model is better than another, my basic idea that I'm telling you right now is to just look at the picture and see if the points go through the data better. So 0.40, we'll say 402 x squared plus 2.039 x plus 50.071. So there's my my model. Determine the function that, well, okay, we just did. Seems like did they want me to say quadratic and then find it? Predict the number of 100-year-old Americans. So 100-year-old Americans in 2010. Okay, in 2010. Now, if I take 2010 and I subtract 1994, what do we got there? Is that 16? I think that's 16. Double check with my handy dandy machine, but I'm pretty sure I'm right on that. We got 16, right? And so that is, in this case, the new x value, okay? So, just like I showed you guys before, we could do x equals 16. Well, see, that's going to be outside here, and there's my model, and so the predicted value is 180. Almost scribble. So if I stick in 16 in for the x values here and obviously here, then I am going to spit out a y value of 185,000. We'll just go with 0.6. 185.6 thousand 110-year-olds, okay, based on the model. Now, predict when there will be 80,000 100-year-old Americans. Now, 80,100, so that's a number over here, right? That's a y value. But what y value is it? According to our model, that's a y value of only 80. So I'm coming back over here, and I'm typing in y equals 80. Now, we're doing this the fast way. We're letting the calculator do the work. We didn't do any solving like we would have done in Algebra 2. and had to probably thrown out the quadratic formula on that one. But the graphing method with Desmos is much faster. So 6.45 years. So if you started in 1994 and you went 6.45 years, that's sometime after 2000. So, maybe, so 6.45 years. Oops. After 1994. So, we're talking 2000.45 years, something like that is. So, almost halfway through the year of 2000, we've hit the 80,100-year-old Americans mark. Anyway, let's see what's next. Okay, I was wrong. I thought we had another example to do, but we do not. So I'll work on the homework that's in the Canvas calendar. Thanks. Bye.